This is a tutorial on multiplication and division of radical expressions. When we multiply radical expressions, or say we multiply square roots together, we basically follow the product property of radical expressions in reverse. Now, we previously used the product property to simplify square roots. And the product property tells us that if we have the square root of two numbers multiplied together, say a and b, that's equal to the square root of a times the square root of b. So if I had the square root of 36, I could have turned that into the square root of 9 times 4. And if I have the square root of 9 times 4, well, that's equal to the square root of 9 times the square root of 4. Well, if we're going to multiply two square roots together, then we're basically going to follow the product property in reverse. So if we have the square root of 3 times the square root of 12, I can think of that as the square root of 3 times 12. The square root of 3 times 12, that's the square root of 36. And the square root of 36 is just 6. Let's try this again. Here we have 3 times the square root of 10 squared. Well, you can think of that as 3 times the square root of 10 times 3 times the square root of 10. Now, these are all multiplied together, so it doesn't matter what order I write them in. So I can write this as 3 times 3 times the square root of 10 times the square root of 10. Well, 3 times 3, that's 9. The square root of 10 times the square root of 10, I can think of that as the square root of 10 squared. If I square a square root, those operations cancel. So I'll just be left with 10. So I end up with 9 times 10, or just 90. Now, multiplying radical expressions also follows the distributive property. Here I'm taking the square root of 3 and I'm trying to multiply it by 5 plus the square root of 2. Since I'm taking this square root of 3 and I'm multiplying it by this whole quantity, and this whole quantity has an addition in it, that means I have to follow the distributive property. So I'm going to take the square root of 3, I'm going to multiply it by 5. Then I'm going to add that to the square root of 3 times the square root of 2. So I have 5 times the square root of 3, and then I'm going to add that to the square root of 2 times the square root of 3. Now, 5 times the square root of 3 I can't do much with. That's just 5 square roots of 3. The square root of 2 times the square root of 3, well, I can write that as the square root of 2 times 3, or the square root of 6. So my solution then is 5 root 3 plus the square root of 6. This is the simplified form. If you wanted to, you could convert the square root of 3 and the square root of 6 into decimals. The square root of 3 is approximately 1.73. And the square root of 6 is approximately 2.45. So what we have here is 5 times 1.73 plus 2.45, which is approximately 11.1. Let's try our next example. Here we have the square root of 2 times the square root of 2 plus 4. Again, we're multiplying the square root of 2 by a quantity that has an addition sign in it. So if we're going to do this multiplication, we have to use the distributive property. So we're going to take the square root of 2 and we're going to multiply it by the square root of 2. Then we're going to add that to the square root of 2 times 4. If I do this, I end up with the square root of 2 times the square root of 2. And then we're going to add that to the square root of 2 times 4. Now, the square root of 2 times the square root of 2, I can think of that as the square root of 2 times 2. I can't do much with 4 times the square root of 2. I can't simplify that anymore. Now, the square root of 2 times 2, that's the square root of 4. And the square root of 4 is just 2. So we end up with 2 plus 4 root 2. And this is our solution. Now again, if you want to get a rough estimate of what this is equal to, you can convert the square root of 2 into a decimal. The square root of 2 is approximately 1.41. So we have 4 times 1.41, and we're adding 2. This is approximately 7.66. Well, now that we've shown that we can multiply square roots through the distributive property, now let's show that square roots still get multiplied when we FOIL. We FOIL when we multiply two binomials together, or two quantities that have an addition or a subtraction sign in them. So if I wanted to multiply 7 minus the square root of 2 times 2 minus the square root of 3, I would have to use the FOIL method. The FOIL method states that we take our first terms in each binomial and we multiply them together. Then we take the outside terms of our binomials and we multiply them together. Next, we take our inside terms and we multiply them together. And then lastly, we take the last term in each binomial and we multiply them together. So if we do this, we're going to take 7 and 2 and multiply them together. Next, we take our outside terms, so 7 and the negative square root of 3. So we're adding that to 7 times the negative square root of 3. Then we take our inside terms and add that to that. So that's 2 times the negative square root of 2. And then lastly, we take our last terms and multiply them together. So we're going to add the negative square root of 2 times the negative square root of 3. 7 times 2, that's 14. 7 times the negative square root of 3 I can't do much with, so this is just negative 7 square roots of 3. 2 times the negative square root of 2, that's just negative 2 square roots of 2. The negative square root of 2 times the negative square root of 3, our negatives are going to cancel because we're multiplying two negative numbers together. So this is just the square root of 2 times the square root of 3. The square root of 2 times the square root of 3 I can write as the square root of 2 times 3, and that's just the square root of 6. So my answer then would just be 14 minus 7 square roots of 3 minus 2 square roots of 2 plus the square root of 6. Now let's look at our next problem. Here we have 3 minus the square root of 5 times 3 plus the square root of 5. These two binomials represent the difference of squares. When we FOIL this out, this is going to end up being 3 squared minus the square root of 5 squared. And we can show this through the FOIL method. When we FOIL, we take our first terms and we multiply them together. Then we take our outside terms and we multiply them together. Next, we take our inside terms and multiply them together. And then lastly, we take our last terms and multiply them together. Our first terms, that's 3 times 3. Our outside terms, that's 3 times the square root of 5. Our inside terms, that's 3 times the negative square root of 5. And then our last terms, that's the square root of 5 times the negative square root of 5. 3 times 3 is 9. 3 times the square root of 5 I can't do much with. 3 times the negative square root of 5 is minus 3 square roots of 5. And the negative square root of 5 times the square root of 5, well, I can think of that as minus the square root of 5 times 5. The square root of 5 times 5, well, 5 times 5 is 25, so this is the square root of 25. And the square root of 25 is just 5. So we have 9. Now, plus 3 square roots of 5 minus 3 square roots of 5. Those are going to cancel. So we're left with just 9 minus 5. And that's equal to 4. Now what's important to notice here is when we took the difference of squares of two binomials with the same square root in them, we actually got rid of all of our radical expressions. We were left with just 4. So now let's talk about dividing radical expressions. When we divide radical expressions, we don't actually divide them, we rationalize them. Rationalizing is basically just rewriting these expressions to get the square roots, or the radicals, out of our denominators. So here I have 7 times the square root of 3 divided by the square root of 5. Now if I want to get rid of the square root in my denominator, I have to multiply the square root of 5 times the square root of 5. This will give me the square root of 5 squared. But if I multiply my denominator by the square root of 5, I have to multiply my numerator by the square root of 5. Otherwise, I would change the value of this expression. Now the square root of 5 over square root of 5, that's just equal to 1. And you can multiply anything by 1 without changing its value. Now if I do this multiplication, my numerator is 7 times the square root of 3 times the square root of 5. My denominator is the square root of 5 times the square root of 5. Now the square root of 5 times the square root of 5, you can think of that as the square root of 5 squared. My numerator, this is 7 times the square root of 3 times the square root of 5, or the square root of 3 times 5. Now when I square a square root, these operations cancel. So in my denominator, I'm just left with 5. In my numerator, I have 7 times the square root of 3 times 5, or the square root of 15. So 7 square roots of 3 divided by the square root of 5 is just equal to 7 square roots of 15 divided by 5. Now let's look at our last problem. Here we have 6 divided by 1 minus the square root of 3. Now we're trying to rationalize this, or we're trying to get our square roots out of our denominator. Now remember, when we were doing the F.O.I.L method before, and we multiplied two binomials together that were the difference of squares, we eliminated our square root signs. So because I have a binomial here in the denominator, I'm going to have to multiply this denominator by its conjugate. Or I'm going to multiply this by 1 plus the square root of 3. And if I multiply my denominator by 1 plus the square root of 3, I have to multiply my numerator by 1 plus the square root of 3. So what we're going to have here is 6 times 1 plus the square root of 3 divided by 1 minus the square root of 3 times 1 plus the square root of 3. Now again, my denominator, this is the difference of two squares. This is going to be equal to 1 squared minus the square root of 3 squared. My numerator, I have to distribute the 6 inside the parentheses. So this is going to be equal to 6 plus 6 square roots of 3. Now my denominator, 1 squared is just 1. The square root of 3 squared, well, the square cancels the square root. So this is just going to be 1 minus 3. My numerator, I can't do much with. It's still 6 plus 6 square roots of 3. So what we have here is 6 plus 6 square roots of 3 over, well, 1 minus 3 is a negative 2. If I divide 6 by negative 2, I get negative 3. So this is going to be negative 3 minus 3 square roots of 3. So if you have a binomial in your denominator and you want to rationalize your expression, you have to multiply it by its conjugate, or 1 plus the square root of 3 in this case. And that completes the tutorial on the multiplication and division of radical expressions.